Okay, are you ready for a mind-blowing fact? It's called the birthday problem. Did you know that in a room of 23 people, there's a 50% chance that 2 people have the same birthday? How could this be? I'm not kidding.
Oh, it's not true.
I swear this is true. Okay, think about it. Think about back in school.
On October 3rd, he asked me what day it was.
It's October 3rd.
You got a lot of classes. The class has like what, 25, 30 people? How often do 2 people have the same birthday? Pretty often, right? Probably like more than 50% of the time. The birthday problem. Okay, what's going on? What is going on? Let me get some chalk. So why is it so much higher than like someone would think? If you ask someone on the street, what's the probability? They'd probably think like, well, 365 days in a year, 23 people, so the probability is 23 over 365, which is way, way smaller than 1 over 2, right? So what's happening is we're not asking what the probability is that someone else in the room has the same birthday as you. We're just asking what the probability that any 2 people in the room have the same birthday. So let's compute it. So as is often the case in probability, it's easier to compute the probability that this doesn't happen. So let's ask a slightly different question. What is the probability that no 2 people in a room of 23 people have the same birthday? Okay, so here's what we're going to do. Label the people, 1 to 23. Put some numbers on their chest, okay? 1 to 23. Let's say that, the first person, let's say, is Joe Schmo, or like Tony Stark, Peter Parker, Wonder Woman, whatever, doesn't matter. What's the probability that the second person number 2, with the 2 on the chest, doesn't have the same birthday as person number 1? Well, let's see. There's 365 days in a year. The first person has some birthday. So there's 364 days left over. So the probability that the second person doesn't have the same birthday as the first person is 364 divided by 365. All right? Now what about person number 3? What's the probability that they don't have the same birthday as person number 1 or person number 2? Well, we've taken up 2 days so far of the year, so there's 363 days left over. So the probability that the third person doesn't have the same birthday as the first person or the second person is 363 divided by 365. So the probability that out of the first 3 people no one has the same birthday is 364 over 365 times 363 divided by 365. Okay, what about the fourth person? Well, to compute the probability that none of the first 4 people have the same birthday, we just take this and multiply it by 362 divided by 365. By the same reasoning, the first 3 people all have different birthdays, so there's 362 days left over. I'm assuming it's not a leap year. Forget about leap years. Who's born on February 29th anyway? It's crazy. Okay, so now what about 23 people? Well, you see the pattern. So we keep going. We keep going all the way to 343 divided by 365. And we multiply all this out. Now, if you multiply all this out, you get you get 0.493. To get the percentage, we just multiply it by 100. So this means 49.3%. So there's a 49.3% chance that in a room of 23 people, no one has the same birthday. Now, we want what is the probability that in a room of 23 people, there are 2 people that have the same birthday. So to get that, we just take 100% and minus the chance that doesn't happen. So what do we get? 100% minus 49.3% is equal to 50.7%. So the probability that there are 2 people in the room with the same birthday is 50.7%. It's actually slightly higher than 50%. So yeah, this is the explanation. If you have any questions about the math, let me know in the comments. I promise you I will reply. And I want to do a little experiment. So what you should do is go to the comments, type out your birthday. If anyone in the group of the 23 closest people to you in the comments has the same birthday as you, I will let you know. All right? You could also, of course, look at it yourself, pay attention, whatever. Yeah, so I hope you enjoyed this video. For more cool things, go to Professor Wolverine on YouTube. Please like, subscribe, comment, share, etc. And I'll see you next time.